in chat. Alright, folks, that's it.
Alright, so we spent a significant amount of time talking about light and how it reflects off things. Now we're going to talk about lenses, and we're going to talk about light going from one medium to another medium and how that changes light. Believe it or not, light can bend.
What?
That's why you still see light even though you can no longer see the sun at the end of the day.
Is that because it's so strong?
You ever thought about that? The sun goes below the horizon and you still see light. Why is that?
Because it bends. Because I'm like, yo, light.
But yeah, I don't.
We're being sarcastic.
Are you calling? You heretic.
All right.
What have you learned?
No, they've got all of them. There's so much homework.
So, this chapter is primarily focusing on the concept of refraction. You've heard of reflection. This is primarily about refracting light. You may have heard of the vocab word before. Have you heard of refraction?
Yes.
Okay. It's the bending of light. This is what refraction is. As it travels from one medium to another. Okay. It causes it to bend. We'll talk about why it bends and how it bends, things like that. Up to this point, we were just talking about light traveling through one medium. What was the typical medium we were talking about?
Air.
Air.
Oh, I was going to say
Okay. As a light ray travels from one medium to another, the medium, one medium it will travel faster in, and another medium it will travel slower in, and that causes the light to bend. Okay. So we're going to talk about all the variables that go on with this, but if you have two different mediums, okay. One medium will cause the light to go faster, another medium will cause the light to go slower, and it will cause a change of direction, which we would say is really just a bending of light. So.
Wait, why does bending light go slower change direction? Just wait.
Wait, but you can't make light go slower.
Not through all medium.
I got that wrong.
Oh, boy.
Oh, well, I mean,
It essentially.
Well, we were only talking about one medium.
yeah, it's not. No, that one actually, I didn't do it.
Oh.
See, light goes real fast. There's your answer. Really fast.
3.098.
I found that. I got that wrong. I found that fast. Yeah.
Man, it's so weird not having talking to.
Why is it taking so long?
Not enough.
It is quiet.
Tomorrow's meeting is gonna go.
So
You gotta plan the rest of the year without it.
Wow.
let's do it, Lord.
I'm sorry. Like usually goes and he's like. So.
Why are you taking so long?
Yep, that's it. That was my response.
Visual aids.
What was
I think I just froze everything.
We broke the school.
Hey,
What?
I don't actually see a Rube Goldberg machine. I just see a jumbled up sweat.
See it?
Kind of hot.
I need to take a poll.
I feel like
I'm more filled out in this sweater, and I'm less.
okay, I'm gonna play this, so I want you guys to be quiet. Thanks.
Light rays that strike the surface of the water at an angle bend as they travel from air into water. This property of light is called refraction. Refraction of light occurs because light travels as waves. When waves travel from one material to another at an angle, their speed changes and they bend. Light waves, for example, move more quickly through the air than they do through water. A beam of light, therefore, follows a straight path as it moves through the air, bends as it enters the water and changes speed, and then continues on a straight path through the water.
Okay, so when we talk about bending of light, guys, we're just talking about bending as it's going from one medium to another. It doesn't like continue to bend while it's going through that medium. Does that make sense?
Unless it's just constantly changing medium.
But how can you prove that?
But if
It
you had a,
smells like a
if you had a,
bagel.
like a frequency of the inspection, like that all the way.
It's just back. My new phrase response be like, well, how can you prove that?
Yeah.
And I would probably just say I can't. Alright, so refraction can be explained with a lot of the stuff we talked about from last chapter. Okay, we know that the speed of light in the vacuum is what? 3.0 times 10 to the 8. Okay? In other mediums, such as air, glass, or water, the speed of light is going to be different and less than your speed of light in a vacuum. So if light travels at 3 times 10 to the 8 meters per second in a vacuum, it's going to travel a little bit slower in any other medium. Some mediums slower than others. Okay? Air is the fastest medium, not a vacuum. Well, vacuum technically isn't even a medium.
There's no gas that's faster than
Okay, maybe I shouldn't state that. I guess I don't know that for sure. That's just the one that pops into my head.
air. Air is fast.
Yeah.
Got it.
Oh, no. All right. So here's what this is. So this is called the index of refraction. It's basically just a ratio. Okay. So you know what C is, correct?
Yes.
Okay. And if all other mediums have a speed that's less than C, okay, what you end up having is the ratio of how light would travel through a vacuum compared to how it would travel through its medium. And that's going to tell you how much it's going to bend and if it'll bend toward or away, which we'll get to as we progress today. Right? Now, we are going to assume that, oh, let me get this book out. I don't have this chart memorized. Now, we are going to assume that the speed of light in air is so close to the speed of light in a vacuum that our n is virtually 1 when we're talking about air. Did everybody hear what I said? Okay? When we're talking about air, it has such a close speed to that of what it would be like in a vacuum that our n for air is going to be virtually 1. And you'll see that I think you have, yeah, you have a chart there, looks like. I'll just turn to that page. And so it's C over V, which remember this is a constant. So if you look at this, which medium is the light traveling the slowest in?
No, it is.
Diamond.
Why did I know
Yeah.
I don't know why
It's alphabetical.
Oh, yeah.
So they are.
Does everybody understand why diamond is going to move the slowest in? Not
It's got the tightest bonds.
It's dense.
Well, I'm not asking you, I'm talking about based mathematically. I'm not talking about what we know about the structure of diamond.
It's got a big number.
It's the furthest from one.
Okay.
What are you looking
Well,
for?
why can't it be like this? Why can't it be air?
Because it's got that very close to it.
Because the ratios are.
The speed of the light medium is.
Anytime you divide by a small number, you're going to get a bigger number, right? Okay. And so the reason why diamond is going to be moving the slowest is the only way to get a larger number is to have, by this equation, is to have the speed be slower or smaller. Okay? So the number, the closer it gets to 1, the faster it moves through that medium. What's the matter?
like sneeze and there's like a little piece of snot on my wrist. And I throw up.
Okay. The further away it gets to one, or the bigger the number gets, the slower it travels through that medium. We're not going to talk about what goes on within the medium that causes it to move slower or not. That's for a different level.
Advanced physics.
Yeah, I guess.
Why is it kind of open?
This is the last year of having this year.
What if you offered physical science
I'm
as
actually here for advanced camp.
Kramer.
He's like,
Closer to one, slower it travels.
No.
No.
If you offer physical
Faster it
science.
Okay,
travels.
so like, remember this is a constant, correct? Okay. For this to be 1, the speed would have to be 3 times 10 to the 8th, right, Cheyenne? Okay. If this number gets lower, n gets bigger. And if this number is getting lower, you're getting slower,
Okay.
right? Because this is speed.
So closer to one faster.
Okay? Now, it says when light passes from a medium with a smaller index of reflection. Smaller index, now I'm going to write this. Smaller index of reflection. Refraction. Gosh. Small index of refraction means travels fast. Okay, so if I go from one that has a small index of refraction to one that has a larger, which means fast to slow, the light will bend toward the normal, and I'll show you a visual on the next slide. First off, we already know what normal is, but I'll explain what I mean when I say bend toward normal versus bend away from normal with the visual. Okay? Then it says when light passes from a medium with larger, which we said is fast or slow.
Slow.
Okay? Into one that has a smaller index of refraction.
Fast.
Okay, so it's really going from fast to slow or slow to fast. Now I know a lot of times they'll give you index of refraction instead. Actually, I like to just think of it as slow to fast or fast to slow, because it helps me understand bending a little bit better. So let me show you a visual here. Okay, first off, I haven't stated this yet. You can see my two mediums here. Okay. When refraction occurs, not all of the light gets refracted. There is some amount of light that gets reflected. Right? Like for example, if light travels into water through air, how do we know that light gets reflected?
Yes.
You said the same word wrong like 12 times today. How do we know that some light gets reflected?
Because we can see the water light, the light.
The
Coming
water
on,
light.
what I was thinking.
We can see ourselves.
Yes.
Oh.
Okay. So and you can actually, yeah. So when light hits the surface of water, you know that some of the light is getting reflected because you can see images off of it. Okay. But not all of the light will reflect. A lot of it will go right through into the new medium and do what? That's the word.
Refract.
Refract.
Diffuse.
Exactly.
If you have water,
No question.
water would be a specular surface, but you have a diffuse.
So specular and diffuse is only referring to reflection.
Yeah, but you said that you can see your reflection off of the water.
Yeah.
So I was curious if that would be diffuse or.
What is going on?
That's the water.
Now, if you look, what we have is air, which has, we know is going to be traveling the fastest through. So we got fast, slow, and here is the opposite. You're going from slow to fast. Now remember, fast means low n, slow means higher n. And n is your index of refraction. Did I write that wrong? You're looking at it like I did something else.
You tell us.
It's the same thing I just showed on the previous slide where it said when the index of refraction is low, I said it's fast. We're just going back. Okay? The same thing can be said here. slow, moving through it slow is the same as saying it has a high index of refraction, and moving fast is the same as saying low. So here's where the bending toward normal and bending away from normal comes into play. First off, this ray is showing what? Reflection. Same with this. This would be the reflected light. This would be the refracted light because you're going through a medium and you're seeing it what?
Changed or bent.
Bend, okay? So then this little dotted line is called our, because normal means
Oh,
this
is
will-
that the FN perpendicular?
perpendicular to the surface, okay? So here, if I look, which way is it bending? Toward normal or away from normal?
It's bending
Away.
away from.
Wait, why is it toward?
If we're going straight, it would be here, so it bends
Oh,
toward
yeah,
the
okay,
normal.
that makes sense.
Does that make sense?
Yeah.
So then this one, when it comes in, if it were not going to bend, it would do that, right?
This one's
So
away.
this one bends away.
Wait, so can you tell me again how we get a high end from having a bigger dividend?
I didn't say that.
What's high end slow?
This is how fast it's traveling. This is just the index
How
of
fast?
reflection. The light is traveling. So how big V is. Low V, high end. High V, low end.
I wouldn't say high V to low
But
end.
air has
It's just
Is
cast.
this
what?
Slow or low?
East side.
Oh,
Yes.
man.
So if you do the speed of light divided by 1, that's going to be a bigger number than if you do the speed of light divided by
No,
2.
no. You're not. N is 1, not N equals speed of light divided by the speed traveling through a medium.
These aren't just, these are just.
Those are N's.
Okay.
Yep. Okay. Did anybody else get confused by that? Everyone good on fast? Moving fast means you've got an index of refraction that's low. So this is what it's referring to when I say fast. Okay? V is the speed of light through a medium. Okay? If it's fast, this number will be bigger, making this number little. Does that make sense? Because this is a constant.
Oh, correct.
Okay, if this is slow, that means the speed it's traveling is slower, making this number
Higher.
bigger. Are you seeing what I'm trying to show you here with high, index, low?
I just flipped.
Yeah.
Is it because the n equals the density of the medium?
It has something to do with the density of the medium. I don't know, it's more than that. But I would say that's a big part of it, because diamond's really dense. Okay, now, here's how I like to think about it. You can tell me whether you think this makes any logical sense. This just helps me figure out if it bends away or towards. If I go from slow to fast, I think I'm going slow and then speeding up. I mean, it's kind of stupid, but that's how I'm thinking. That helps me remember slow to fast, bends away. And fast to slow, I'm going and then I'm slowing down. Okay. If it doesn't make any sense to you, that's fine. That just helps me be able to do it quickly. If you have to figure out whatever will help you remember it, that just is something that, when I think of speeding up, I think of going away faster.
Yeah, another cat.
Wait, are you saying that when it goes into the...
When it moves away from normal, it's always fast.
Oh, I see. 'Cause
When I go, I'm
of,
slow and then I'm zooming away, so I think of it like zooming away from the normal.
So is it only
Because
gonna
it's
do
going
that
fast.
when it goes back into the normal?
What'd you say?
Is it only gonna refract or speed up when it goes into a normal?
No, it's only going to speed up when it goes from a slow moving medium to a fast moving medium.
So you can have like,
If
you
the
don't have to
medium's
have the air, you can just have like diamond and water in this scenario.
yeah, diamond and water would work because diamond's slow and water is faster. Yep. Yep. Anytime you're going from a slower medium to a faster medium, it's gonna speed up and it's gonna bend away from the normal. These are just two examples. You have a whole list of different index of refractions for different mediums, and as long as the medium you're starting with is slower than the medium you're going into, then you're going to bend away. And the opposite's true. if you go from fast to slow, you'll bend towards. All right, so this leads us to Mr. Snell.
What?
Okay? Because objects appear to be in different positions due to refraction. You're going to see a visual on the next slide. You probably can see it already. Okay? Due to Snell's law. So what this is, what do you think the eye represents here?
Index.
Incidence. So that'd be the incoming light, medium, index of refraction, and the incoming light angle, and that angle is going to be with respect to what? Normal. Okay? And the R, do you think, represents what?
Refraction.
Refracted medium, or the second medium it's traveling in, or it's bending in. Okay? And again, this would be your index for that second medium. This would be the index for your first medium. And again, that would be the angle from normal as well. So if I were to go back, this would be my incidence angle, the angle between the normal and my light ray. This would be my refracted angle, the angle from my refracted light to my normal. And then whatever the N is for air would be Ni. And whatever the N is for glass would be my NR.
That's just the.
So what you can do then is, if you know your two N's and you know the angle your light's coming in, you can exactly predict what angle it will come out. Does that make sense?
Yeah.
So is incidence always
Thanks.
Oh, I just remember
Makes you
there's
feel great.
no final this semester.
Well, I don't know, I haven't gotten very far in the project.
Nothing to
So.
look forward to.
Wait, could we go back?
Excuse me.
Or maybe not go back, but
Go back?
to
To what?
the equation. I think
It's not on your.
No, it is, but the
Not the
bottom.
part
Like the explanation of it is.
Yeah.
Right there?
What?
I can sit here and wait till you get it.
Oh, wow. Well, I think so.
But this is gonna be done by the end of the semester.
No, it needs to be done by open house.
When's open house?
April.
Tomorrow.
It's next week.
Oh.
Can you remember March?
When did it?
Well, again, it depends on how, this is a reflection of you guys.
Okay,
And me.
Reflection.
Oh,
You
Alright.
were going fast.
This, when I first saw this little visual, when I finally understood what goes on with refraction, it made so much sense to some things I did as a child. Did you ever, when you were a child, get in a lake or something and see a fish below you, and you want to try to grab that fish? You ever never did that? I'm the only stupid child.
I did that.
Absolutely, you would try to grab the fish.
I
You
was
like
like, give yourself a spot.
I was so scared.
I just wanted to even touch the fish. I didn't even want to necessarily grab it. I was just trying to touch the fish, right?
I try and whip it with hooks attached to string to try and fish it out.
Oh, really? Wow.
Work, slave.
Oh, you're right.
Work.
Well, you gotta do is sit there and
Okay,
play this.
but,
It's like, which of those-
okay, so I guess maybe me and a few other gentlemen here are the only ones who did this. But I would always try to grab the fish, and I'd be so mad because I never could touch it. And part of it might be because the fish was, skirting away fairly quickly. But the bigger issue is I was not grabbing at the right location.
Oh.
So,
What I mean by that is, due to light reflecting, okay, so light hits the fish, okay, comes through the water, hits air and bends, and hits my eye. Well, my eye, again, does not process that light can bend. So, my eye is going to create an image of the fish that's above the actual fish's location. So when you try to grab what you're trying to grab is actually the image of the fish and not the fish.
What?
Virtual fish.
Oh!
see our fish.
So if you're using a Christ.
This is where the actual fish is, because light comes off and bends and hits my eye. The eye takes it straight back because it's going to be, our eyes, our brain can only process light going in a straight line. We've probably already come to that agreement from last chapter, correct? Yeah? Right? And so every time I tried to grab the fish, I was not grabbing low enough. But I had no idea, because I thought that that was actually the fish, when actually it isn't the fish, it's just my image of the fish.
So the bending
So
never
would you see
moves.
two?
What do you mean the bending? Well, I mean the food,
If you move
food.
yourself, you can see it just fine. It doesn't move with you.
No.
So in that picture, it's showing the cat floating, so it can see exactly where it's at.
No, this is what the cat sees, this is what the fish sees. So the fish, when it looks up, it looks at the cat, it looks like the cat is floating.
Aren't fish like more
Does that make sense?
Can't see
Okay?
forward.
So the cat sees a fish that is higher than what it's supposed to be due to bending of light, and the fish sees a cat that's higher than what it actually is.
So if I had goggles, I went under the water and I looked at someone standing on a dock, it would look like.
Well, the dock would move really quickly.
But it would hard.
Oh, that's true.
No, they just look real high up in the air.
Yeah, this is actually kind of a little bit of a faulty image.
Yeah!
Now that you say that, does everybody understand why it's kind of a faulty image?
Yeah.
Because if you were if you were with goggles in a lake or something and looking up, you would see everything shift up, not just.
It's just the cat.
Yeah. Just the cat.
That would be a little creepy. All right.
Smell. My name's Marcel Michelle.
Sometimes I use a Dorito for Hey, look at we got nanometers.
Oh!
Oh,
Nano. 6?
Negative 9.
Oh, I think I know this.
Negative 9.
I didn't know. I was asking.
Cool.
Why you tell me to shut up?
Don't need a shut up.
So 5.89 times 10 to the 6 meters. No, 5.89.
It's to the negative 9.
Oh,
Okay,
okay.
you don't really need it for this problem, but just, well, people haven't finished taking the test, so I won't take it.
Come on.
Just give us. So Lauren, it's 5.89 times 10 to the 6.
A light ray of wavelength 589 nanometers produced by a sodium lamp, travels through air, strikes a smooth, flat slab of crown glass at an angle of 30 degrees to the normal. Find the angle of refraction. Okay. We have an NI, an angle of incidence, a refracted, and an angle of refraction.
Oh, what's a crown glass? What's a crown glass?
Alright. So, let's look up here and see what information we know. First off, we want to solve for this, correct?
Yeah.
Yes.
Amen.
Okay. Then it says that the light travels into the glass at 30 degrees, so that would be
Angle of incidence.
the angle. Whoever's making that whistle noise, stop it. Okay. Then it said we started in air, correct?
Correct.
So we said that we're just going to assume the index of refraction for air is 1.
Are we always going to assume
It's actually 1.0.
And then glass will be R.
1.00, like, yeah.
And then
Okay.
NF, sodium.
And then NR,
What's
I
glass?
wrote F.
NR,
I replaced it.
Is it N1
So-
or NI?
NI.
Theta I.
Oh, wait.
glass?
So you're going to have to look in your little chart that I gave you in your note packet to figure out what the index of refraction is for each of these individual objects.
1.52.
1.52.
What's crown glass?
What is what?
What's crown glass?
I do not know.
Well, it's 2 types apparently.
Yeah, no, crown
Flint
glass.
and crown.
And one's faster.
That's what it's.
Wait, why did
Look
it
at-
say 589?
Are you looking at it right now?
I'm doing it.
Kramer,
What's the matter?
why did they use the 589?
No reason.
Really?
Wow.
That's there for no reason.
I mean, it tells you the wavelength of light.
It wasn't there for no reason, Cole. You were able to find
Last
out
day
what
that
it was.
Negative 9.
Yeah.
It's positive.
Nope.
Negative?
No. It's glass, maybe that letter iron.
Alright,
Glass, maybe with
so
letter.
I have sine of theta here. How do I get rid of sine?
You do the inverse side. Radians or degrees.
Degrees, maybe. Degrees. Polar.
I like to do the way.
Glass at angle infinite.
You do you. Okay? So what I did is I divided by this and then took the inverse so that I could get the angle. Everyone following?
What happens if you just put the numbers straight into it?
You still have to take the inverse of this because you have to isolate the angle. So you'd have to get rid of the sine.
What if?
I mean, you can do the math separately and then take the inverse of your total answer. That would be fine.
If the angle had over less, that would real math.
You don't know how to get sine to the negative 1 on your calculator?
have a
I do, I just, it's plain.
All I did
Line.
was divide by this. That's what's in here. And then getting rid of sine here, I would take the inverse of sine, which would get rid of sine on this side. And I gotta do it to the other side as well because it's an equal expression.
So why is that side inside of the inverse?
That's this side.
Are we not doing? I thought you said you guys do it to both sides.
I did, that's what this is.
So you only have to do it once.
Well, I did it to this side and got rid of this side.
Oh, because I didn't, got it.
I'm not
I
sure
keep getting
where we're
negative
No, it's
0.7.
because-
misinterpreting. I'm not sure I understand what exactly you're
I
messing.
probably don't understand.
What, negative 0.7?
I don't understand
No, I think we're asking
right
right
now.
Okay,
It's
yeah.
19.
Are you saying why does this sign not remove this sign?
Oh,
Is
yeah,
that what you're saying?
Yeah, change it to.
Degrees.
Darn, I thought maybe I had it.
It's gonna be a bone cheek, just keep going.
Okay. So then you just gotta plug in the numbers here. I mean, I could just replace them with the numbers, but you probably already have done that. What you guys get for an answer?
19.2.
Yeah.
It's weird that you're bi.
So this would be my refracted angle. Okay. First off, let's see if we can understand some things here. I'm going from n of 1 to n of 1.52. This means fast
To slow.
slow. Are we bending toward or away from normal?
Going toward.
Toward, and the angle suggests that, right?
Yeah. Because you're just like,
30 to 19. So that would agree with what we have been talking about conceptually in class.
Is
It's
it,
going through slower, so.
We're going from fast to slow.
Is there ever a situation where like you're going from like super fast to super slow, so it just actually makes the light go vertical?
There's a situation where if you're at the right angle, it actually causes it to go right in between the mediums. So like, what happens is if this is your line between the mediums and that's your normal, there's an angle where it will go like this.
So you just think it's like.
It's called total internal reflection. So then you would just get you would only see reflected light. But we'll talk about that later. I want you guys to do this one here.
Is this from Aaron?
No, it's not.
Entering a diamond from the bottom too.
Okay, so yeah, you're entering diamond.
like,
I have no idea who you raised.
That would be your NR. When you look up the diamonds number. Wait. Entering diamond. Okay, yeah. Yep. This would be NR. And this would be your NI.
Oh man, it's not air anymore.
Nope, not air.
Oh, so it's not one?
No. So you just look in your your anytime you're finding an angle, you can just assume you have to take the inverse of sine.
You would play your Stevie.
Wait, what are you saying?
Angle.
For the
So it's OR.
angle of refraction. It's that one. Sine of, what are we doing, water? Or 30 degrees.
What would be the O on?
And what's diamond, 2.4 something?
419.
What's the theta?
What's what?
Theta is 30.
Oh.
Yep. Right here. I don't know why I put 300.
First one.
That's probably what's going
Nine.
No, actually, no, I lied. 4 degrees.
First one's 16.
Yeah, maybe that was a degree, I don't know. Okay, did you guys get an answer for the first problem?
Yeah, 18. 18? Oh, 16?
I told you.
Oh,
It's actually like 15.9.
Oh, come on, hold.
I know 15.95.
Okay.
Wow, you're bold.
Okay, well, I only
Now-
entered on the three digits.
If I'm going from 30 to 15, am I bending towards or away?
Towards.
Towards, it
Oh,
makes sense.
wait.
Diamond, it's going really slow in. So it's gonna bend towards when you go from fast to slow.
Yeah.
Same thing's gonna be the case for this next guy. It's still gonna bend toward, but it is gonna have a different angle. Did you guys solve the second one?
We're going from diamond to fake diamond.
I thought
Diamond
fast
to
and
fake.
slow
Those
was the
cubics are
way.
fun.
What?
I thought fast and slow was the
It's
way.
fake diamond.
Yeah, but I don't know that's
Slow, fast.
It's basically.
Slow, fast, speeds up and shoots away.
27.1.
What about?
Like fast, how fast to get that?
Fast.
Fast.
Slow.
27.
27, yes.
Which is still bending towards.
Still did.
You did. You wrote that. I did.
No, you didn't. Since slow fast.
I guarantee you.
There's 12 problems. 12 problems.
So you might want to fix that before you
Yeah,
get.
right.
I don't even have notes anyways.
Yeah, you're right.
You have like 17 tests.
I have at least 30 tests.
That's so bad.